Hey guys, all right, we are going to do chapter 10 now. I've already actually done this and then apparently didn't have my microphone on, so that's just how it goes sometimes, I guess. All right, so this chapter is over chemical reactions, and it would have really been a good one to have been in class because it's just kind of a cool lab. But, oh well. We'll just go on. So this one's all about chemical equations and sort of like what happens before and then, if you mix things together, then how it becomes, something different. So first thing, chemical formulas. Empirical formulas are the simplest whole number ratios. So it gives H2O as an example. I don't really like that one. I like, let's say, C2H4. The empirical formula of that would be CH2. How did I do that? See these two numbers right here? See how they're both divisible by 2? I just divided both of those by 2. So if you divide 2 by 2, then you get 1. If you divide 4 by 2, you get 2. So this is the empirical formula of C2H4. The molecular formula is the actual number of atoms. So that would be like C2H4. That is the molecular. Okay, that's the actual. And then the third type is structural. So that's just going to show you kind of like how it would look if it was bonded together. And, this can get really important whenever you're dealing with like pharmaceuticals or, just even fats and stuff like in food, saturated fats versus unsaturated fats. All of this formation really matters. And these double bonds versus single bonds, that matters as well. So if you think that stuff doesn't matter in your life, it really does as far as, medicine, nutritional issues, and things like that. All right. So this is giving you empirical or molecular formulas. So some of your homework is going to ask you questions like, write the empirical formula for this, the molecular formula for this. So that's what it's actually talking about, okay? Empirical formula, this is typically going to be like between ionic, molecular formulas. These are showing you like covalent. Remember the difference between the two, ionics, metallic, non-metallic together, whereas covalents, nonmetals. Okay, and this is just showing you like another example of a empirical type formula. So if you had C6H12O6, if you divided all three of those numbers by 6, then it would be CH2O. Okay, so another example. All right, so here we've got molecular and formula weights. And so in order to find the formula weight of a compound, it's pretty simple. You do have to look at the periodic table for this. So let me see if I can find it. Okay, so remember when I said I already did this video and the microphone wasn't on? All right, that was stuff from before. All right, so see this formula, this C12H22O11, that's what's known as sucrose, which is it's the actual name for table sugar. So what does the 12 tell you on the carbon? It tells you that there's 12 of them. At this point, you should kind of know that, okay? The 22 tells you that there's 22 hydrogens. The 11 tells you that there's 11 oxygens. So what you do in order to find formula weight, it's pretty simple. What I would suggest doing is kind of making a table. And it doesn't really matter how, like, what order you make the table, but I kind of do this. Okay, so the atoms that we're dealing with here, we've got carbon, hydrogen, oxygen. Well, how many carbons do we have? We have 12. And then what is the mass of carbon? So if I like zoom in right here to carbon, see this 12 right here? That's where that number is coming from, that 12 units right here. That's where they're getting it. So just kind of round to whatever it is. So since this is like 12.011, that's like basically 12. If you were doing boron, see how it's 10.8, I would round that to like 11 when I'm doing it. So 12 times 12, 144. All right. Hydrogen, how many are there? There's 22 of them. So the mass of hydrogen is 1. So that is 22. And then how many oxygens are there? There's 11 of them. And if you multiply that by 16, because if you look over here at oxygen, this one is like 15.999, so that's around 16, okay? Then that gives you 176. And if you add all of these up, get the total, that should give you about 342. That number right there is the formula weight. Okay? So, formula weight, molecular weight, kind of interchangeable as far as those two words. So, if it refers to formula weight or if it refers to molecular weight, just that's what it's wanting, is this process right here, okay? All right, hopefully that makes some sense. Let's go on to our next slide here. All right, so I think this was the next slide. Hold on. Yeah. All right, so this is for percent composition. And this is like saying, well, what if you just wanted to know how much percentage of that whole compound, just one of the elements in there was of that whole compound. So you get this equation, and that's just given to you. So it says the atomic weight of the elements times the number of atoms of elements divided by the formula weight of the compound. And it's all multiplied by 100%. So let's do our last example so we've got C12H22O11. Okay, let's just do the percent composition for, say, carbon. Okay, so carbon, what is the atomic weight of carbon? Well, you have to kind of go back to your periodic table. Hopefully you've got it, but the atomic weight of carbon is 12. There's 12 carbons, so that's the number of atoms in that particular compound. And then the formula weight is what we found earlier when we added all of that stuff up, and it was 342. And then you multiply that by 100. Let me see what that is. So it's about 42%. Okay, and that's for carbon. So that's how you would do the percent composition of just carbon. What if you had to do it for, say, hydrogen? So you do it the exact same way. There's the atomic weight of the element of hydrogen. What is the atomic weight of hydrogen? If you look on the periodic table, it's basically 1. And then that's the bottom number, by the way, not the top number. So if you look at the bottom number, it's like 1.0079. So it's basically 1. And then how many are there? There's 22. You divide that by 342, multiply by 100. So let me try this again. It's about 6%. Okay? If you wanted to do it for oxygen, I'm just doing these as examples, guys, so that you guys have an idea of exactly how to do percent composition. So there's 11 of them. The atomic weight, oh wait, I did that backwards. It's okay though. I switched these, by the way. There's 11 of them. The weight of oxygen is 16. You divide that by 342 and multiply by 100. So 11 times 16. So it's about 51%. Okay, so if you add all of these up, you should get about 100%. Okay, so So that's how you do percent composition and formula weight. And this slide right here is just giving you another example. It's saying, and I do like this example because this kind of brings in stuff from chapter 9 that we just got finished with. So just kind of like, hey, you don't get to just forget it. So if you didn't understand it, you really need to. So this is saying that sodium fluoride is added to water, and it wants you to figure out what the formula. First off, it wants you to write the formula for sodium fluoride. And this wasn't given. I mean, they give it to you on this slide, but in the problem, they don't. But you could find that really easy. How do you find that? You have to look at the periodic table, and you have to figure out what the ion is. So if you look at the periodic table, let me bring it back up really quick. Maybe. Okay, so if you look over here at sodium, sodium's right here. What group is it in? It's in group 1. So that means that its ion is going to be +1. Why is it positive? Because it's a metal. And you go on over to the right side of the periodic table. Come back down. There we go. And fluorine is over here, so it's in group 7. It's a halogen. So what is its ion? And it's a nonmetal, by the way. So since it's a nonmetal and it's right by those noble gases, it's a -1. And if you do that little crossover thing, then you get NaF, right? So that's exactly what it's showing you right there, is this NaF. Well, you might have to come up with that, but obviously for something else. And then you would have to find, this is the molecular weight or the formula weight. So how many atoms of sodium are there? Well, there's just 1. And then you have to look at the periodic table, and you see that the periodic table says that the mass of sodium is about 23. So you multiply 1 times 23, and you get 23. And then you have 1 fluorine, and fluorine's about 19. So 1 times 19 is 19. And you add those together, and you get a total formula weight of 42. Then it goes and it does the percent composition for both fluorine and sodium. Okay, so that's what we just did on that previous slide for sucrose. So this is saying the atomic weight of fluorine is 19. There's 1 of them. You divide that by 42, multiply by 100, and then the percent composition for just the sodium, for the fluorine portion of it. No, for the they have this backwards. No. See how, they do. Because see how this says 4 sodium and then they've got 19 units for fluorine? I don't know, that was weird, but oh well. This is for fluorine. So about 45% of the compound is for fluorine, and then about 54% is sodium. I don't know why this says 4 fluorine and then it gives you sodium right there. Weird. Oh well. All right, so I'm going to stop the video, and then we'll start a new one on chemical reactions.